Continuing with our work on graphing, topic 5 of chapter 2, we're asked here for example 1 to simplify this equation and put it into slope-intercept form. So y equals mx plus b. And then we're asked to graph it. This is multi-step. So we have 4y minus 6. Get rid of parentheses. This becomes a negative 15. And this becomes a positive 6x. So we have 4y. Going to transpose this negative 6 to this other side, where that makes that a negative 9. A negative 6 on this side becomes a positive 6. And then this is a plus 6x, putting it in this form, and then now dividing everything by 4. We get y equals, simplifying this, 3/2 x minus 9/4. Now, 9/4 is about, well, actually, 2 1/4. So when we go to plot that, you'll see. Okay, now we'll raise it up, and we'll put it on the graph. So the first thing we want to do is plot our y-intercept here, which is a negative 2 1/4. 2 1/4, right about there. And then now our slope is run over 2, which is right there. It's positive, so now we're going to go up 3. So 1, 2, right about there. And we take our line tool, and if you're using a straight edge, you can make this nice. Here it is. Remember, there's an infinite number of points. Now, if you have trouble graphing it because they're asking you to put points in that are hard to plot, depending on the graph they give you, you may have to make a t-chart and put in some values that give you whole numbers so you can plot them better. So number 2, the same protocol. Put it in slope-intercept form by simplifying and then graphing. Pause, give it a moment. So I'm going to take the 2y from this side, transpose it, becomes a negative 2y. So this is 4y on that side. Transpose the 6x to the other, comes a negative 6x minus 2. So I've got it in the beginning. Now I divide everything by 4. And I get y equals a negative, simplifying this, 3/2 x minus 1/2. So now plotting it, a negative 1/2 is right there. I'm going to go over 2, but now since this is negative, to the left. So there's 1. And I do that mentally. Then I'm going to go up 3. So there's 1, 2. And there's my second point. Use my straight edge. And I get something like that there. Okay. And there's an infinite number of points. And the same thing here. Again, plotting the y-intercept, if that doesn't work, and you're not allowed to do it that way, you have to make a little t-chart. Now for number 3, this is a multi-step, and we're looking for whether the lines are parallel, perpendicular, or neither by putting them in slope-intercept form. Y equals mx plus b, and that way we can compare the slopes. So looking at this one, we're going to simplify it. 1, just take away the parentheses and change these signs. Now get rid of these parentheses. This is going to be 8x minus 8y. Okay, now we're going to get all of the x's over to one side and numbers over to one side and all the y's over to the other side. So let's do the y's first. On this side it becomes a positive 8y, so this is going to be 5y here. Let's get the x's. Bring this over. This is going to be 10x. So add 2x or transpose. And then we have just a negative 1 here as we move this 1 to the other side. All right, now we divide everything by 5. And we get y then equals 2x minus 1/5. That would be this equation. Now let's work this one, doing the same thing. So we got 5y. Now we'll put the 10 right here, 10x. And we're going to bring this positive 4 over as a negative 4. So this becomes a 5 here. Divide everything by 5. And we end up with y equals 2x plus 1. So again, we inspect our slopes. This line is 2. This line is 2. Our slopes are the same. So again, it's kind of confusing, lots of work. We find that these equations are actually parallel lines, and that's what they may be asking you for as part of the next step. All right, let's go on to number 4. And again, we need to simplify our equations. So what technique can we use here? We want to get rid of that 3. Well, we're going to multiply every term by that fraction's denominator, 3. Now on this side, this is all one term because of this grouping symbol, division bar. The 3's cancel out, so we're left with 3y plus 10x. And then now we have to take the 3 and multiply it by this x, and we get 3x. 3 times 3 is 9. So making it a lot simpler, want to get all the x's on one side, so we got 3y. Going to transpose this to this side, where it becomes a negative 10x. So this leaves us with a negative 7x plus 9. Now divide everything by 3. And I get y equals a negative 7/3 x plus 3. Putting it into slope-intercept form is your best way to check these out here. All right, so I'll start simplifying this one. This is going to be a negative 7y. Going to bring this 3x over to this side, it becomes a negative 3x. So this becomes 3x then, and plus 14. and now divide everything by a -7. Now, looking at our slopes to determine which of these it would be. Well, here this is a -7/3, and this is a -3/7. They're reciprocals of each other, but the product of them would be a positive one, not a negative one. In order for them to be perpendicular, one would have to have the opposite sign. So it's not parallel, it's not perpendicular, so this would be neither. Now let's take a few moments to graph them because that's a skill we want to work on as well. And I'll make the screen a tad larger. So to graph this first one, a +3. So 1, 2, 3, a dot on our y-intercept. And then from that point, the slope, a -7/3. So we're going to go over 3, and then up 7 brings us here. So this line, and you're putting this on your graph too if you have one. Oh, I moved it a little bit here. Let's do that one again. There we go. Beautiful. Now I'll do the next one in black. Now this is a -3/7 at 2. So at a -2 dot there, and again, this is going to be 7. 1, 2, 3, 4, 5, 6, 7, right there. And now up 3. 1, 2, 3. So this line will look like this. Now notice there's an intersection here, and we're putting two lines on one graph, which is a skill we're going to be using in our next section. Okay, let's go on. Now they're giving us some rather challenging equations, and that's a skill you want to work with too. So simplifying this first one. Now you could multiply everything by 2, but again on inspection I see something will cancel out here. So let's put it over here. So this will be 3 minus, and I'll put this in parentheses here, 2y. I'm going to put this over the common denominator 2, minus 2x over 2. And then the rest is straightforward, 5x plus 6. Okay, let's see what we can do here with this simplification. This is going to be 3 minus, now here the 2's are going to cancel out and I'm just left with a y. Here the 2's will cancel out and I'm just left with an x. Now some of these steps you could do in your head, and I'm showing them for detail here. So with a negative, in a sense, -1 out in front here, this becomes 3 minus y plus x now equals 5x plus 6. Okay, so we now have left on this side a minus y. I'm going to bring this 3 over to this side as a -3. So 6 minus 3 is 3. I'm going to bring this x over to this side as a -1x. So this becomes 4x. And I need to divide everything by a -1 or multiply through by a -1. So this becomes y equals a -4x minus 3. All right. Simplifying that. Now this one's a little easier. So a -2y, transpose this to the other side is negative 8x. Make sure we see that negative there. Plus 6. Now divide everything by negative 2. I get y. Now negative 8, negative 2 gives me a positive 4x. And this gives me a negative 3. Okay. Again, as we inspect the slopes, this is a negative 4. This is a positive 4. They're not reciprocals, even though they are opposite signs. So again, this is a neither. But we do see a common point of intersection here. But let's just do the graphs now, and we'll keep it the same size. So a negative 3 is right there. Now this is a negative 4, so we're going to go over 1, up 4, over 1, up 4. 1, 2, 3, 4. Just getting some more points there. And this line will look like so. Again, being negative slope and changing colors. This is going to be, again, I'm going to black now. Goes right there. Now over 1 to the right and up 4. 1 to the right and up 4. And then using my line tool. And that's what we have. Okay, I think there's one more to go, and again, lots of practice. Now, for this one, they want you to look at these points, and they define vertices of the, and then they want you to look at the quadrilateral four-sided figure that results. And then they say, find the slopes of the indicated sides and simplify your answer. Now I'm going to use, you could use the slope formula, but I'm going to use the diagram. And let's make this bigger. And plot these. Negative 2, negative 2. So negative 2, negative 2. We have a point right there. 4, negative 1. So 4, negative 1. Right there. 3, 3. So going over 3, up 3. And then negative 3, 2. Negative 3, 2. Okay, I don't know if you see it or not, but we've made a parallelogram. Let's just sketch this in here. Sketch this one. Sketch this one. Sketch that one. So what are the slopes of these lines? Well, these two lines are parallel because it's over 1 and then up 1, 2, 3, 4. So the slopes of this line and this line is a negative 4. And in a sense over 1, but don't write that 1. That's negative 4. And this one is over 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4, 5, 6. So this one has a run of 6 and a rise of 1. Let's check out this one. 1, 2, 3, 4, 5, 6. Exactly. So the slopes of these two are the same. So this would be a parallelogram. They're not, are they right angles? Yeah, I guess they would be. parallelogram have, or not necessarily right angles, but as I see this, this is like a rectangle that's just been tilted to the side. Okay, so again, depending on the steps that they're asking, again, we figured out the slopes. We found that they were parallelograms. And this will wind up this lesson.